Thank you. Thanks so much for the introduction, and thanks everybody for the warm welcome. We'll see if you feel the same way at the end of the talk, but that was nice. So yes, my name is Charlie. I'm a developer at Atlassian. I live in Sydney in Australia. You might not know Atlassian, but you might know the product that I work on called Jira. But what I'm going to talk about today has nothing to do with Jira. And outside of my job as well, I'm a Google developer expert in web technologies and a Mozilla Tech speaker. So I know that there's been a few other speakers who were part of these groups in the past few days. So if you have any question, I think feel free to ask us. But the title of this talk was like strike a pose, and I don't know if there's any Madonna fan. Actually, I forgot I should have said that first. But so I really like human-computer interaction. So when I work on Jira, it has nothing to do with that. But when I go back home, I love to explore different ways to interact with technology and interfaces and devices in a different way. Maybe not with your computer or your phone, or maybe using the phone a different way. So this is why I called this talk Strike a Pose, because it's from the song Vogue, and I don't know if you know it, but voguing is a type of dance where you don't really follow certain steps. You kind of just express yourself in different gestures, and it's like really who you are and how you feel with dance. But we're not going to dance today. This is not what we're going to do. But we are going to use our own gestures to play a game of Street Fighter. So that's the goal at the end. That's the goal, yes. So to do this, there's a few different ways, but the way we're going to talk about today, you need this to get started. So we're going to use Arduino. I'm really glad that some of you did workshops yesterday that use hardware, because it means you kind of already know a little bit what I'm going to talk about. This one is probably not the one that you use. This one is Maker 1000 that connects via Wi-Fi. But on top of that, so we're going to be holding that piece of hardware. We're going to use machine learning to find patterns in the data that we're tracking in our movements. And we're going to do absolutely everything in JavaScript. So for Arduino, for Arduino, we're going to use Johnny 5. And for TensorFlow, we're going to use TensorFlow JS. OK, so step one, gathering data. So at first, we got nothing, right? We just have an idea. We want to be able to play Street Fighter with our body movements. And what I mean by that is that when I want to punch, then I'm just going to actual punch. And then there's three movements. I have punch, uppercut, and Hadouken. I don't know if it's the real names, but let's just call them like that. So gathering data. We're going to do that with the Arduino. So I used a Wi-Fi board because if you use a basic board like the Uno, it has to be tethered to the computer, and I want to be able to move around. I want to be able to play from anywhere. If I wanted, I could play from the back of the room as well. But the Arduino itself is going to run a program, but it doesn't actually have any built-in sensor to track motion. So instead, we're going to add as well an MPU 6050, which is an accelerometer and gyroscope combined together. And this is really good to track movements, because I'm going to become an MPU 6050 right now. So let's say, how does an accelerometer work? So you can track motions in three different axes, so X, Y, and Z. And accelerometer, let's say if I go from left to right, that would be the X-axis, then you have the Y-axis and the Z-axis. But if you use the accelerometer just by itself, you're not really going through life walking like this, right? So we use the gyroscope to also get the changes of rotation. So it means that we're going to have to track three more axes, but with rotation. So you're going to have like X-axis rotation like that, Y, and Z, I think. So in the end, we're going to have 6 points of data that we're going to be able to track over time as we are moving. But there's one last thing that I did as well, which is a button. And I added a button because I want to track the data only when I am doing a gesture. You don't have to do that, but I think it was, as a first prototype, it was easier to only get the data from my gesture, so I can train the algorithm to only find patterns in the data when I'm holding the button. So when I'm going to hold the button, I'm going to do the gesture, and when I release it, I only take into consideration that data coming from the sensor. So this is for the hardware. But in terms of code, we start by, always requiring a few node modules. We're going to use Johnny 5, the file system, and the Etherport client to set up our board. As it is a Wi-Fi board, you have to connect to the IP address of the Arduino and a certain port to communicate with your computer. And then once the board is ready, once that is set up, we're going to set a button as well on the pin that you want, in this case A0. And then we create a file, like a stream, to be able to write data to that file. So in this code sample, I hard-coded the name of the file, like sample punch 0, because you're going to have to record data a lot of times. So we're going to like punch 0, then punch 1, then punch 2, and this is how I spend my personal time. So I do that at home, and after you open the stream to write to a file, you also have to instantiate with the sensor, the MPU 6050. You give it the pins to which it's connected, and as soon as you have change of data from the sensor, so as soon as you're actually moving, we are going to track that data, but we're only writing to the file when we're holding the button. So there's this event listener that's listening to when you're holding the button down, and we're writing all that data to the file. Once we release the button, we end that stream, which means that the rest of the data that is still coming from the sensor, we're not actually adding it to any files. So in the end, we expect stuff that looks like this. And I say expect because this is not exactly what I got, but this is what I wanted. So this is real data, but this is not coming from the Arduino, and I'll talk about that a little bit later. So this is actually not at all what I got. I really wanted that, because I knew that it kind of worked when I built the really first prototype of this. What I got instead was something like this. So we still have 6 points of data, X, Y, and Z, from the accelerometer and the gyroscope, but the data is not precise enough. Don't worry about like trying to read it, but if you look at it maybe a bit later, you'll see that the data, the points of data look exactly the same over all the lines. So it's over time, there's actually not that much of a change coming from the sensor. I haven't quite figured out why yet. Maybe it's my sensor, maybe it's my code, I'm not sure. I just know that in the end, you can train the algorithm, you get your model, but the thing is the accuracy of this particular data is not really good. So I had to move on, but I'll cover that a bit later. So this is one important thing if you ever get into machine learning. It's not only about how much data you get, it's also about how good it is, because I was getting a lot of data from the Arduino, but the quality of it was not good enough for the model to be accurate. Okay, so now we recorded our data many times in a lot of files. But you can't really feed that to TensorFlow yet because, well, at the moment, it's just lines in files. So it's not really useful. So we have to do a bit of data processing to transform the data in a way that TensorFlow can work with. So if we imagine that I have the nice file of data that I wanted, we're going to start with that. So at the moment, it's just a file with lines. But the first step to transform it into something that we can use, we're going to transform into an object of features and label. So I think this is probably one of the main terms in machine learning. Features will be the characteristic of your gesture, so all the data that that's in the file. And the label will be, so you can't really work with strings with TensorFlow, it has to be numbers. So we're just converting the name of our gesture to a number. So if you have a gesture array with the punch, uppercut, and Hadouken, then punch will be index 0, so you just set the label to 0. But that's only for one file, so one sample. What we want is to do that with all our files. So we're going to end up with a massive array of objects that represent our gestures in features and label. But that's not it neither, because that's the first step, to kind of put the data in a way that we understand it a bit better. We can work with objects, but TensorFlow doesn't work with objects. TensorFlow works more with stuff that looks like arrays, but it's more like tensors. But let's just talk about arrays. And at the moment, we have objects, so that's not really good. So we need to split between features and label. So we're going to have here, we're going to end up with something kind of like this. And I'm going to go a bit line by line, because I know that probably right now it's like, what? So as I said, the labels will have an index of 0, 1, or 2, because I have 3 gestures. So index 1 would be punch, Hadouken, and uppercut. And they're going to be, so we are going to have a multi-dimensional array of labels and features to map gestures to each other. So the first level of our multi-dimensional array for labels is going to be mapped to our first level of features as well. And if we go a bit deeper, it means that the first punch that I record is going to be mapped to the data that I get from it in our features array. And you go on and on. So the second one will be mapped to the second one in the first level of the array. And you go through that like one by one. So we're getting a bit, I don't know if you noticed, I didn't actually show you any code to transform the data because it has nothing to do with TensorFlow yet. At the moment, it's basically just if you know a lot of array methods and pushing objects and stuff like that, you do that with just normal JavaScript functions. It's not yet something, we're not yet using any TensorFlow methods. But now we are getting more towards something that TensorFlow can work with because it's only multidimensional arrays and it's just numbers. There's no string, no objects, so we're getting closer. And now the thing is, now we need to move on to converting to tensors. So think of tensors as a data type that TensorFlow can work with. So this is where I'm going to show a little bit more of code that is TensorFlow specific, because we have to use the built-in methods to be able to transform our multidimensional arrays into tensors. So the first step is to shuffle the data, because we don't want the algorithm to get used to the way we are fitting our labels and features. So if you remember the slide before, I had an array of zeros, an array of 1, an array of 2 to map all the gestures. But the thing is, if you fit it like this, the algorithm is not going to try to really look at the data and think of a gesture. It's probably going to look at, well, the 3 previous ones that you gave me were punches, so I'm going to assume that this is a punch. But if you shuffle the data, you kind of force the algorithm to get more, to try to really understand what the data, what makes a punch and what makes an uppercut and things like that. So once the data is shuffled, we start using, well, in this case, it's a tensor 2D from TensorFlow, where what is going on here is that we're using our shuffled features, and the second parameter of that function is going to be the shape of the tensor. And that means that it's going to be expecting the data to be coming in a certain way. And our first argument is the number of samples per gesture. So if I train a punch gesture 20 times, then I'm going to use the number 20. And then the total number of data per file, the second one in the array, is the number of let's say, data input in a file. So you know how I'm tracking 6 different values for my gestures, X, Y, Z, for accelerometer and gyroscope, but I have between, like, I could have 50, 100, 200 lines. So you just have to multiply these 2 numbers, and that will be the shape of your tensor. It's basically the amount of data in one gesture that it's going to be looking for. And then labels tensor. So this is going to be a tensor 2D because the label is just an integer. It's just 0, 1, or 2, but it's not going to be an array of numbers. So we just move from tensor 2D to a tensor 1D. So now we have really the data type that TensorFlow can work with. We have tensors. But what we need to do is we're going to do the next step, which is splitting between the training set and the test set. Because what we want to do is we already know our data is already labeled. We already recorded it in files, and we named them with the right gesture. So we're going to use 80% of our data set to give it to our algorithm to learn patterns. And we're going to keep 20% of it to validate that the predictions from our model are actually right, because we already have the data labeled. So if the algorithm or the model predicts that it's a punch, but actually you know from your data file that it's an uppercut, then you can just retrain until the accuracy gets a bit better. So to do this, here we're just calculating what 20% of our sample is. But, and then we're just slicing tensors. So I'm not going to go that much into that, because I think that's not the part that matters the most, but it's just like you don't really care how it slices. You can just use the slice method. But we're ending up with a training set and a test set of features and labels. So now that we have this, we really have our data kind of ready. So what we have to do next is we actually create the model. At the moment, we just prepared our data, but we don't have the model yet. So to create the model, this is where it kind of becomes, it's not really a science, it's kind of like you try things until it works, well, at least that's what I do, where I create a sequential model, and then you can add different layers. I have 2, but you can have 4 or 6, and you can change the parameters. I'm not quite there yet to understand what everything does, but when it works, I don't touch it anymore. So let's just pretend that it's fine. So, and just before fitting the model, so before launching the training, you have to pass a few different parameters of the optimizer that you want to pick, and the metrics that you want to track, and things like that. So this is where really, if you want to create your own, you could copy and paste, but you could also play around with different features and see what makes your accuracy better. So then, once we have that, we have to fit our training features and training labels inside our model, and we just pass it. Epochs is just going to be the number of steps for the training, and the validation data is our test features that we're going to validate against. Once the training is done, we save our file. So the actual model is going to be saved as a file in your application, so you can just use it later. So now we created our model. It's there with all our data, but we want to use it, right? So the step 4 is going to be to predict. To do this, we require TensorFlow. We probably don't need to look at the whole code, but we require TensorFlow, and then we have our array of classes or gestures, so Hadouken, punch, and uppercut. We load our model to be able to use it, And we have the same code as we had before when we were recording the data, but this time we're using it to predict. We're waiting for data changes from the Arduino and from the sensor. And when the button is held, we are kind of like keeping all our data into a variable. We're pushing it into an array because once we release the button, I want to use this new live data that the model has never seen before to match it against one of the gestures that it's been trained against. So once we release, we keep our data that we just recorded. But at the moment, we also need to transform that into a tensor because it's just an array, and TensorFlow can't work with just arrays. So we create a tensor 2D as well with our new sample data, but this time the shape is going to be different because we're giving it only one input. So the first number is going to be 1, and 300 is going to be, that's kind of arbitrary, you can change it. It's basically because I used 50 lines in each file, so if you have 6 times 50 is 300. So the model is expecting data 300 points of data to work. You can change that, it's fine. And once our live data has been transformed into a tensor, we can just call the predict method on the model, and it will give us back a label, so a number, and so 0, 1, or 2, and then you can look at that into your gesture classes array to get the actual label of the live prediction. So this, what is really cool about it is like I trained it the way. Every time I do a punch, there is no way I could do the exact same punch that I did before, because if we have 300 or more points of data, there's no way that the value from our accelerometer would be exactly the same, even if you tried, 100 times. So it means that you are more free to do whatever gesture as long as it looks like a punch to the algorithm. So the way it's learned pattern from data, it will probably understand the values or the stuff coming from the accelerometer and make sense of it and match it to one of the gestures that you tracked. Okay, I feel like that was heavy. Okay, so now that I talked about how it is supposed to work, I'm going to try to show, hopefully, that it works. I mean, I know it works, but I don't know if it will work here. Yes, okay, so you know how at the beginning of the talk I told you about the data that wasn't really good because it was, I don't know yet why, but I know that it wasn't really good. So this is the sketch. This is how I put the sensor, the button, and the Arduino together. But the thing is, well, I knew I wanted to do a demo. So the thing is, I switched sensor because I didn't want to come on stage knowing it wouldn't work. So now I feel like maybe it will work because I switched. But it works the same way. So that was really cool because it means that I was actually able to just not even change the code that much, just change where the data is coming from. So I used a Daydream controller that you usually use with the Daydream headset, the VR headset from Google. And I use that one because it also has a built-in accelerometer and gyroscope, and it also has a button. So it's like basically everything that I used with Arduino, but just a different sensor. And it gives me the really precise data that makes it actually quite accurate. So it's like, awesome. So what is supposed to happen now is something like this. So I have a game. I put a GIF because if it doesn't work, at least now you know it works. But I'm supposed to, I'm going to do a punch. I'm going to try the 3 gestures, and it's supposed to be doing this. OK. Oh, my God. OK. Last time I tried to demo it a little bit, it did not quite work as planned. OK, if anybody has Bluetooth on right now, feel free to disconnect it. I've had issues in the past. OK, let me just have a sip and, OK. OK, I have my predict file. There's an error, but don't worry about it, it still works anyway, so I didn't fix it. OK, I need, come on, don't let me down. It's not on. Oh, I knew. OK, I'm waiting for the message that tells me that this, OK, this is on, it's on. Whew, I gotta be quick. Wait, I haven't done anything yet. OK, so I'm gonna do like this. And, OK, don't let me down. Whew. You fucking let me down. OK. No. Never try Bluetooth ever. OK, yeah. It's, OK, you're on. I'm gonna refresh. Oh, why not? What? I can't even refresh. I have other demos, so I have to Is there a Wi-Fi? Oh, OK, Rain. Come on, give me the notification on. OK, I'll try one more time, and then I have to move on to the next. OK. See if I try that. Yay! Okay. And if I try like, woo! They're supposed to. I was supposed to have sound. I don't know if we need to turn it on, or if it's my thing. Well, all right. Can I try again, or is it off? It off. Okay, that's fine. It crashed. So that's cool. I'm done with this one. Okay. So, but the thing is, then I started thinking, okay, I have a gesture recognition system in JavaScript, but I was like, well, what else can I do with it? So this is where it's going to get even more lame. And wait, is it supposed to? Is that sound? So what? What you can do as well is wand movements. So if there is any Harry Potter fan, I know there's a few because we talked about it. Yeah, so if you don't know Harry Potter, so usually you're supposed to tell the spell, like Alohomora and Expelliarmus and stuff like that. But then when you grow in your level of wizardry, you don't have to say the spell, you can just do the movement, and then there's a third level where you can just think about the spell, but we're not doing that today. But we're gonna do the one where I'm gonna move. I just trained two gestures, and it's supposed to do something on the screen. And I hope it's going to work, because it's going to be very embarrassing if it doesn't. But I trained Lumos and Expelliarmus. So, man, you really have to try. Like, I really like that demo. So you got to work. Oh, no, not that. Wait. Give me 1 second, localhost. Okay. I just needed to work once. I want you to work once. Okay, oh, why you crashed? I don't know why this is crashing, but it's happening, it's fine in my room, and it's not fine on stage ever. Come on, I want the Harry Potter one to work. At least once. This is really weird. Hello? Well, you haven't even done anything. Okay, again, maybe third time is the right time again. Oh, no, you were listening to what? Okay, come on. I really like that one. Okay, come on, do it. Oh. It didn't do anything. What? Oh, okay. Oh, okay. So, okay, that's the thing. It's like the shape of, I'm going to talk while I try to do it again. The error here is the thing is like the model is expecting the shape to come in a certain way, and if I do it too fast, it doesn't record enough data, which means that it will crash. So I can fix that. I just haven't done it yet. Come on, I need to do the Expelliarmus. All right, otherwise I'll just move on. But this is like not even localhost. That has nothing to do with Bluetooth. Come on. No. Okay, well, I'm just going to go back to my room and cry. That's fine. I need to move on. That's cool. Another time. So, but what else? So what I was really, as I got into kind of like that rabbit hole of trying weird stuff, I was thinking, well, okay, I'm having fun, but I want more people to have fun. Like, that's boring to play by yourself. So I was like, okay, it works with an Arduino, and it works with a Daydream controller. But you know what else has a built-in accelerometer and gyroscope? Your phone. So it has a built-in sensor to track both, direction and orientation as well. And you can access that stuff in JavaScript with the generic sensor API. So what we could actually do is just replace the code that gets the data from a piece of hardware. So in this case, that's obviously just pseudocode, but you would generate a gyroscope, like you would listen to a gyroscope and accelerometer, and with the event listener reading, you would have access to this data, and you can then do whatever you want with WebSockets or even lighting up some hardware or whatever. But the thing is that, well, when I thought you could, I was like, well, I can't say you can and then not do it. So I'm going to try to do it. And this one, actually, I could do the Harry Potter one with my phone because it will work. So, okay, I'm going to do the game one with my phone. So I have, so this is just running locally. I'm using ngrok to be able to communicate with my phone on the same port. So if I'm going to do the game one, just to show that it's working, or it should be working. That would be easier because it's not Bluetooth. OK, so I have the game here, and I have a page on my phone connected. No. Oh, yeah, OK, that's fine, that's fine, that's fine, that's fine. You're not really connected. Oh, I lost the Wi-Fi on my phone. Oh my God. No, are you for real? OK. Oh, I'm back. OK, I'm on. All right, OK. So what's going to happen is that I'm going to do the same kind of thing where I press on my screen, I start recording data, and when I release my thumb on my screen, it should do the thing. Let me just. OK. Well, that wasn't the one I tried, but that's fine. Let me try if I do that. That wasn't the one I tried neither, but you know, it's doing something, so yeah. Oh, good. This, you know, it really didn't go as planned from beginning to end. OK. I probably won't have the time to do the Harry Potter one. I can show you later if you want. But yeah, so just before I finish, just a little recap if you want to know how to build that kind of stuff. So you have to start with getting the data. I use certain sensors, but if you have others, you can use really whatever gets you data. And I used accelerometer and gyroscope, but you could use really anything. You could use a flex sensor, a touch sensor, or really whatever, light sensor. But once you have the data, you need to transform it a little bit so that it can work with TensorFlow. Then you have to split it between the training set and the test set. You have to train your algorithm, and finally, you can run the predictions. So just before I finish, I'm going to say something that I've said before, but I'll say it again. I usually say that useless is not worthless, because I know that you're not going to go back to work and be like, you know, fuck everything, let's just do gesture recognition. But I learned a lot. I learned a lot about the fact that Bluetooth is just, you shouldn't use it. But you learn a lot while doing that, and that is something that really gets me super excited about just building stuff, because I think there's so many different ways we could interact with technology in ways that we want. Because the thing is that I trained it with my gestures, but I could let anybody actually use the sensor, and as long as you do something that looks like a punch, it is going to recognize it as well, but it's going to be your gesture. It's just going to be trying to be mapped to something it's been trained with. So yeah, I'm sorry for the bad demos, but that's all I had today. I'm going to probably share the slides with the resources. Maybe tomorrow I need to clean up some stuff first. But thank you very much for your time.